these problems that I put up here are done in much more detail than you would normally use to rationalize the denominators, but at least it shows all the steps that you're thinking through as you move from the original form to the final answer. So here you can think of using the property the square root of a over the square root of b equals the square root of a over b, which reduces to 1/7. And then you go back the other direction, square root of 1 over the square root of 7, rationalize by multiplying top and bottom by radical 7, and you get square root of 7 over 7. Fourth root of 2 over the fourth root of 3x, we have to multiply by some expression, top and bottom, that will remove the fourth root in the denominator. You can think of this as 3x to the 1/4 times 3x to what power would allow me to multiply these powers by adding the exponents and getting an exponent of 1, and that would be 3/4. So that's why I multiply by the fourth root of 3x, the quantity cubed. That's where this 3 comes from. So now I can multiply these two numerators together because they have the same root index of 4. 3 cubed is 27, times 2 is 54, x cubed. And in the denominator, I showed this step, but the truth is you should be able to go right to here. Same idea in the last problem. Start simplifying before you rationalize the denominator. So we have 2 cube roots. I can say this is the cube root of the quotient, which allows me to cancel out a factor of x in the numerator and a factor of y in the denominator. And now it's a little simpler to visualize rationalizing. Same deal. To get rid of this cube root, I have to multiply by a cube root that will allow me to combine the radicands so that the exponent becomes a 1. So to the 1/3 times 5y to the 2/3 gives me 5y to the first power. Or you can think of it this way. If I multiply these together, I get 5 cubed, because I got a 5 squared here, and a y cubed, because I got a y squared and a y. The cube root of 5 cubed, y cubed is 5y. So there you go. The idea is that hopefully you can actually someday visualize going from here to here in one step. But it takes practice. So there you go.